Welcome, ladies and gentlemen, to Integrated Math 2. In today's episode, we will be discussing Chapter 4.2.2, which is selecting a trig tool. In the last episode, we actually got into this in the last problem here, when we have to determine which trig tool to use based on the angle's relationship to the given sides of the triangle. That's ultimately what this section is going to reinforce once again. Before writing anything, or before getting started with 4-68, I do want us to copy down this diagram where we are reminded that cosine of the angle is equal to the adjacent side over the hypotenuse side. Sine of the angle is equal to the ratio of the hypotenuse, the opposite over the hypotenuse side. And then tangent, as we've done many, many times, is the ratio of the opposite side to the adjacent side. And so often a diagram that I tend to use for this right triangle is I'll draw a right triangle with the sides x for the adjacent, y for the opposite, and r for the hypotenuse. And so if I was to do this diagram real quick, I would say that sine of the angle theta would be y, which would be the opposite side from the angle, over r, which is the hypotenuse. Cosine would be x over r, again, adjacent over hypotenuse. And then tangent would be opposite over adjacent. That would lead me to y over x. And as long as we keep asking ourselves this question, here's what I'm seeing. I see an angle with whatever sides. What trig relationship should I be thinking of? Then I think we'll be in good shape. Please make sure that you keep in mind that the triangle needs to be a right triangle for these ratios to be applied. They don't apply to every single triangle. So please don't make that mistake. People tend to think and overgeneralize this idea. So in part A here, we're looking at this 28-degree angle, a side that's opposite, and a side that's hypotenuse. Angle opposite hypotenuse screams sine to me. So 28 is equal to x over 19. Multiply both sides by 19, and you get 19 times sine of 28 is equal to x. There's our calculator-ready version. Our calculated version is going to be 8.92. And there we go. There we have it. In B, you could use a calculator if you wanted to. I don't know if we're going to need one. We have an angle, an opposite side, and an adjacent side. This does tell me about tangent. Tangent of 45 is going to equal 8 over x. Now, we could totally do the multiply by x divided by tan 45, or we can remember that when you have a 45-degree slope angle, the slope ratio will always be 1, which means you can actually fast forward straight away to x equaling 8. In C, the top angle is 61 degrees. From 61 degrees perspective, I've got an angle that's adjacent. I've got a hypotenuse. Angle, adjacent, hypotenuse tells me that I'm dealing with cosine of 61 is equal to adjacent over hypotenuse is going to be 18 over x. So I'll go and multiply both sides by x here. So x cosine 61 is equal to 18. Divide both sides by cosine of 61, and what I get is x is equal to 18 over cosine 61, or I could call that approximately 37.13 units. So again, this is all about identifying the side relationship with the angle in question. Let's move on to D, E, and F. We'll keep on going with this train. Again, angle, opposite, hypotenuse. I am thinking that this is sine. So sine of 25 degrees is equal to 6 over x. So multiply both sides by x. You get x sine 25 is equal to 6. Divide both sides by sine 25. Whoops. Sine 25. And you get x equaling 6 over sine 25. Now, what does that equal as a decimal? That's approximately equal to 14.20. So hopefully you're starting to see the pattern of thought here. Even if you're not that quick at it, just think about what you have when you have an angle and the sides that are given. So in this case, I've got an angle, I've got an adjacent side, and a hypotenuse. That tells me that we're dealing with cosine. So from here, cosine of 60 degrees is going to equal 8 over x, adjacent over hypotenuse. And so from here, that's going to let me see that cosine of 60, I'll go ahead and multiply both sides by x on either side. So x cosine of 60 is equal to 8. I'm going to divide both sides by cosine of 60. So I get x equals 8 over cosine of 60. Now, in the last section, we learned that cosine of 60 was actually a pretty particular value. It ends up being 1/2. So you end up having 8 divided by 1/2, which is 16. And there's our calculator ready form. And then from here, this f right here, again, angle opposite hypotenuse looks like sine. So that's going to be sine of 30 is equal to x over 42. And I'm going to multiply both sides by 42. So x is equal to 42 times sine of 30. Whoops, not 60, 30. And so x is going to equal 21, because as you put in your calculator, you're going to see that sine of 30 is also 1/2. Now, one thing I want you guys to pay attention to is, apart from knowing it that quickly, notice how this 30 dealt with sine, and it gave me 1/2. This angle had 60 dealing with cosine, giving me 1/2. And notice that they're both right triangles. We'll talk about the relationship between those opposite angles in the next problem and how I was able to get those values so quickly. Let's move on to the next 3, though. Okay, so from here, it looks like I've got a 0-degree angle, and I've got an opposite over adjacent. So I'm going to say tangent of 0 is equal to x over 63, opposite over adjacent. So if I multiply both sides by 63, I'm going to get 63 times tangent of 0 is equal to x. Now, if you put tangent of 0 in your calculator, you're going to get 0. And 0 times 63 is 0. So from here, that should make sense with a calculator. But hopefully what else should make sense is that when my angle here is 0 degrees, what that really means is that this thing isn't drawn to scale. And what's happening here is that the hypotenuse is really slammed down onto the vertical line because I have an angle of elevation of nothing, which means the rise has also got to be nothing. Hopefully that makes sense. And in the next example here, we've got an angle adjacent and a hypotenuse. I'm dealing with cosine of 73 is equal to adjacent over hypotenuse. So multiply both sides by 3. So 3 cosine of 73 equals x. That's my calculator ready form. And x is going to equal 0.88. Calculator ready and calculated. And the last one, angle opposite adjacent, screams tangent. Tangent of 42 is equal to opposite over adjacent, so x over 12. So multiply both sides by 12, and you get x equaling 12 times tangent of 42. And when we finally calculate that, we're going to get 10.80. Oops, let me make a little Tetris block right there. Okay, so that is selecting a trig tool. We do have a couple more problems to do, but hopefully you're getting used to the tempo of how I look at the triangle, I look at the angle, I look at the sides, and that is how I determine which trig function I'm going to use. I'll be back with the next problem. In 4-69, we're talking about Marta arriving at her math test only to see that she forgot her calculator, and she wants to do as much of the problem as possible. So this is on the first problem of the test. Marta has to solve for x in the triangle shown below. Using her algebra skills, she writes and solves an equation. Her work is shown below. Explain what she did in each step. So what Marta did was she saw that there was an angle, an opposite side, and a hypotenuse, which means she saw sine happening. So she set sine of 25 equal to 29 over x, which is opposite of her hypotenuse. She multiplies both sides by x and then divides both sides by sine of 25. It says in part B here, Marta's answer in part A is called an exact answer. Now use your calculator to help Marta determine the approximate value of x. So in this case, x is approximately equal to 68.62. And that would be after we calculated 29 divided by sine of 25. So now in part C, they're talking about Marta's teammate Ziv said he solved it differently but got the same answer. He used cosine of 65 equals 29 over x and explained why he got the same answer. So from here, what Ziv did is he found the value of this angle using the triangle angle sum theorem and got this guy to be 65 degrees. Now, from the 65 degree angle, the 29 is actually adjacent to it, or next to, right? The 29 side is adjacent, and the x is still the hypotenuse, which is why he used cosine as his ratio instead of sine. So what this problem is trying to teach you is that depending on the angle you're looking at, your opposite and adjacent sides might be different. So in the case of part D, it says solve for the y in the diagram using both sine and cosine. Make sure both strategies result in the same answer. So if we solve it outright based on what we're seeing here, we're looking at an angle of 53 degrees. We have an opposite side and a hypotenuse. So in version A of this, or rather version 1, that's going to be sine of 53 is equal to y over 5. Again, why did I choose sine? It's because I've got an angle, opposite side, hypotenuse. Multiply both sides by 5, and I get y equals 5 times sine of 53. That ends up getting me y equaling 3.99. So let's talk about version 2. Version 2 is when I solve for this angle right here. So what I'm going to do is I'm going to take 180 and I'm going to subtract 90 and 53. When I do that, that becomes 37 degrees, which means if I do cosine of 37, right, from the 37 degree angle, y is now adjacent. So that's going to be y over 5, right? Again, I used cosine because from the 37 degrees perspective, y is now adjacent and no longer opposite. Multiplying both sides by 5, I get 5 times cosine of 37 is equal to y. That's my exact form. Calculator ready? Or calculated. Do we actually get 3.99? We do get 3.99. So either way you cut it, that ends up being the answer. Again, the point of this problem is to show you guys that depending on the angle you're evaluating, you will choose a different trig function depending on what is now opposite and what is now adjacent. So a couple of different ways you can solve each triangle. I'll be back with the last problem. The last problem, 4-68, is kind of a preview into the next section, but they're asking us now to solve for angles. And we normally don't unless we know the angle outright. And so luckily in these three examples, we do know the angle outright. When I have an angle that produces a slope ratio of 9 over 9 or 1, that means that the slope angle must be 45 degrees. In part B, I'm looking at this angle right here. It has a slope ratio of 1/5. We haven't dealt with this in a long time, but hopefully you guys remember. That was 11 degrees back when we first started doing tangent. We saw that tangent of 11 degrees had a slope ratio of approximately 1/5. And then in the last one, we just learned in the last section. So if I have a slope, it's not a slope ratio, but it's a hypotenuse to delta x ratio of 5 over 10. So I'm going to rotate him out. And that was exactly the same as when this was 60 degrees being 2 and 1 here, which means the angle has to be 60 degrees. And so these are all known angles that we've had from previous lessons, previous trig tables, but in the next section, we're going to learn of a way to solve for the angle no matter what the side ratio is, and we'll get to that in the next section. So as always, leave comments or questions in the comments area, and I will see you all in the next episode.